Thank you so much, and welcome to sunny Porto. It's great to see you all here. I'm glad to be here. It's been 6 years since I've been to Porto, and between the stairs and the food, I'm not sure. I think I'm getting in better shape, but we'll see how it goes. I'm here to talk about software design, and rather than tell you the nitty-gritty about how you do this design or that design, I want to take a step back and talk about the context in which design takes place. I think a lot of people have the sense that software could be producing far more value than it currently is. And the question is how to get there. People work very hard at it, and yet we still seem to be under-realizing our potential. So that's the topic for today. In 2005, I was invited to be on a panel with Larry Constantine and Ed Jordan. And Ed and Larry, 25 years before that, so in 1980, had published a book called Structured Design. How many people have seen Structured Design, the Green Book? Okay, ancient scrolls from the mists of time. So I had this book as a college textbook. And so when I was asked to be on a panel, I decided it's probably time that I read the book, because nobody reads college textbooks. So I started reading this book, published in 1980, and I was astonished at what I found in there. In structured design are the equivalent of Newton's laws of motion for software development, and expressed very clearly, but with examples that no longer made sense. So these are the fundamental forces that affect the software that we develop every day. And yet, we'd kind of forgotten the original definitions and these original concepts. So at that time, I swore I'm going to bring this material into the present day. So the examples in the book are things have paper tape and punched cards and this big debate between assembly language and higher level languages and who knows which one's going to win. So I thought, well, this material needs to come forward. The concepts, the thinking was really clear, but the examples are not so much. So I started in 2005. Last year, I finally published the first of a series of books on software design called Tidy First. So it took 18 years for me of taking this activity that I felt comfortable and confident doing, that had this very clear explanation in the book, Structured Design, and me trying to explain it. I didn't get it. I got a little bit of it. I didn't get it. And I kept trying and trying and trying. And finally so book writing, I hadn't written a book in 15 years, and I had forgotten how painful it is. Book writing is an exercise in scope management. For me, it always starts with, here's a topic. There's no way I could put that into a book. It's way too small. And I start writing, and then I realize, oh crap, there's way too much to go into one book. So which third of this am I going to cover? Oh, but that's way too small to fit into a book. And then I write, and I realize, oh crap, that's way too much to go into one book. So the book I finally published, it's called Tidy First, because this is the question, the software design question that programmers face every day. I have to change some code. It's messy. Do I tidy first? And the answer is sometimes yes, sometimes no. Probably yes, but don't get carried away. There, now you don't have to buy the book. So that was the first slice of it, and I'm currently working on a sequel, which talks about more at the level of refactoring. And as I sat down to write the book, okay, I'm finally ready. I've spent 16 whatever years preparing, sat down, put my fingers on the keyboard, and the first words off of my fingers were, software design is an exercise in human relationships. Oh, I thought, no, that's not it. I need to erase this. Wait a minute. What does that even mean, software design is an exercise in human relationships? And I realized that this sense that we have that software could deliver more value really boils down to the relationships on the team, the relationships within the team, the relationships of people with themselves. That's this tidy first moment. I have to change this code. It sucks. Like, I can do this. You know, I'm smart enough, and the pain will go away eventually. Well, at that moment, you could also choose to take care of yourself and say, and it can be as simple as, I have a big function, this part does this, that part does that. I put a blank line in between them. That's a software design decision. It makes your life better. The next time you go and look at that code, you'll be able to see more quickly what's going on. And yet, as programmers, individually, we don't think to take care of ourselves in that way, for whatever reason. And then, when it comes to taking care of each other, it's a whole nother set of complications. And I don't know about you, I don't want to stereotype you, but interpersonal relationships is not my strong suit. People are endlessly confusing. But it turns out, if you want software to deliver more value and you want design to be part of that, taking care of your relationships with other people and using software design to take care of each other is part of realizing that value. So, I'd had all this preparation. I had no idea that the point of my research was this humanist perspective, and then I was quite upset that that was what came out of my fingers. So, the rest of what I'm doing is trying to understand that and explain it in a way that people can take ideas and begin to apply them. So I'm going to live present my slides. I don't like slides, so here we go. Here's a basic cycle in software development. You have some idea, you implement a feature, and then that feature gives you more ideas, and then you implement more features. Okay, so this is look, if I was an investor and I'm investing in your company, I'm going to say, well, you know, what have you implemented? What have you implemented? Oh, how about this? You implement something, and we go back and forth and back and forth. As programmers, we know that that's not all there is to the story. Because like the swan swimming in the lake, underneath this is the structure of the system. The way the elements are, how they relate to each other, how you deploy things to production, all that matters to programmers in a way that it doesn't matter to somebody looking at this process externally. And this tidy first idea that I mentioned is the flow that says, well, we have this idea, it's going to be hard to implement, so we're going to change the structure so that it's easier to implement, then we're going to implement that feature. And that's a legit flow, that's a valuable way to do development. Sometimes it pays off immediately. Oh, doing this the hard way would take me 3 weeks. I could spend a day making it easier to do, and then it'll take me 2 hours. Sure, absolutely should do that. But the intuition that I and lots of other programmers have is we invest way too little in the structure and way too much in the features. And that pushes costs out into the future, which we end up paying. So if we want software to deliver more value, and we are under-investing in structure, how do we make structure a first-class citizen in software development? So that's what I'm going to talk about today, is that change in perspective. How do we think about this whole problem in a way that we can spend more on structure and achieve more value? But one of the thinking tricks that I use all the time is when I have a really difficult problem, I want to acknowledge just how hard the problem is before I get started. I look at other people. Sometimes they'll say, well, there's a problem, it's kind of big and messy, I'm going to pick this little subset and do something in this little subset. And my habit is exactly the opposite. I want to say, oh, no, it's worse than you think. Let's acknowledge how much worse it is, and then we'll go ahead. So the next part of the presentation is, what are the constraints on software development that make it so hard? So I will get to the geeky stuff. I'll talk about coupling and cohesion and power laws and all that, but I want to deal with the harder problems first. The first set of constraints are entirely human. Because we're dealing with people, yeah, I know. Wouldn't it be nice if it wasn't this way? But there you go. They're entirely human. So it's things like incentives. Part of the problem, part of the challenge in software design is that people's incentives don't align. You have people who want to deliver features. You have other people who have to wake up in the middle of the night to if there's a production problem, and their incentives don't align. So DevOps, for example, was originally trying to align those incentives. The incentives are never going to align perfectly short term, and yet we have to find some way of working together. Like, what are we going to do next, even though what you want isn't exactly what I want? Long term, the incentives tend to align. But that's, if you're worried about your bonus in 3 months, it's really easy for what's good for me and what's good for you to be different. Another aspect of the humanity of software design that makes it difficult is aligning authority and responsibility. By that I mean, if I make a decision, I experience the consequences of that decision. So if I make a change to the code and I break something at 3 a.m., I'm the one who wakes up and fixes it. That sense of skin in the game, that sense of immediate consequences, makes relationships between people work more smoothly. If I know that you're going to be the one who's waking up at 3 a.m., I trust that you're not going to be making mistakes. In the same way, in a different way than if you make mistakes and then the operator gets a call and they call somebody else and and it's 2 weeks before you even find out, the feedback loop isn't closed there. And that affects the quality of our relationships. Now, as I've looked at 40 years of capitalist relationships, Aligning authority and responsibility is really hard in the first place, and maintaining that alignment is also really hard work because it's so natural to just say, that's somebody else's problem. And if you can get away with that short term, it's kind of better for you. So how can we design in a way that aligns authority and responsibility? This is the kind of thing, I have an API, you call that API, I want to change it. Now what happens? The aligned authority responsibility, I have the authority to change the API, but with that comes the responsibility of helping you migrate your code, as opposed to just saying, oh, not my problem. Now you're mad at me, because you don't want to be changing this API, you want to be implementing the next feature. And I just made your job harder. And now we're not getting along. And now the next time I want to change the API, you're gonna say some words to me. And it's not gonna go more smoothly. As opposed to, all right, I'll change it, I'll help you change it. Now it's finished, it's fixed. I've learned something in the process. You've learned something. I had to go slower for a second, but the overall effect is more positive for both of us together, and our relationship remains strong. So these, as I said, especially for geeks like me, these are difficult issues to deal with, but the problem is much worse than this. There's another element of the context of software design, which is just basic economics. And if I think back to some of the bad ideas I've seen in software design, like, oh, let's just design it up. Before we start implementing features, we're going to design the whole thing and then it'll go smoothly. That's not going to happen. But it's not going to happen for a bunch of reasons, including just basic economics. The first imperative in economics is survival. There's a great book called Ergodicity by Luca Delana about the importance of survival. There's this cognitive bias called loss aversion, where losing a euro feels worse than winning a euro feels good. Which the cognitive scientists for a while thought, oh, well, that's irrational. It's the same dollar, euro. But every euro you lose is that much closer you are to being broke. So avoiding losses actually makes sense from a survival standpoint. So what does survival mean for software design? It means you do, especially in the early stages of a project, you only do as much design as you need to do in order to survive. Now, as a programmer, this bothers me. I want to make things all beautiful and easy. Let's keep everything tidy all the time. If that helps you survive, great. And if it doesn't, you shouldn't do it. So the second element of economics is this is about timing. As I studied software design, I realized I didn't disagree with other people so much on the what, like event sourcing, for example. Great software design move in the right context. But what I disagreed with people was about when. When should you introduce that? And I had a insurance-oriented project, and I had to implement the net present value calculation, which I'd sort of heard about, but it wasn't until I implemented it that I got kind of an intuition about what net present value, like what's the effect of net present value. And so I urge you to go and implement it yourself and get a sense of it, because it's a powerful shaper of thinking. And here's the insight is more money is exactly the same as money sooner. And paying less and paying later are exactly the same, economically equivalent. So thinking back to the early days of object-oriented programming, and we were going to have these fantastic frameworks, and we're going to spend a few years building the framework, and then we're going to zip all these applications out. That flies in the face of net present value. We're going to have 100 people build a framework for 2 years. That's a lot of spending sooner. And it would take an enormous amount of saving later to actually make that pay off. So the intuition is, if I can push an expense out into the future, I'm going to do it. If I can pull revenue sooner towards the present, I'm going to do that too. Even if I end up spending more money over time, this net present value strongly affects when I should be making these decisions. Now, we've just come out of 15 years of zero interest rates, which as a programmer, I thought, how's that going to affect my life? Well, it really does. This effect of more money and sooner money intensifies as interest rates go up. And now we're all in this new world where we got used to not really, it doesn't matter economically so much when something happens from this net present value point of view, except now it suddenly does. And as engineers, as managers, we've lived with this set of assumptions sometimes for our whole careers, and now the rules of the game have changed, which make the timing of expenses and revenue more important. As software designers, we can affect when we spend money and, to a degree, when we earn money. And I didn't make up these rules. These are the rules. And I want to be adapting to them. The third one is optionality. Why do we design software at all? So that we can change it. End of story. If we didn't have to change the software, the design doesn't matter. So if we're talking about coming up here and making an investment in structure, it's to enable some kind of change. Imagine you have two systems, one of which has a certain set of money coming in and money going out, and then the other one has exactly the same cash flows in and out, except the second system, you could change it this way, you could change it that way, you could scale it up, you could optimize for cost, you could address a new market. Which one are you paying more for? Definitely the one with more options. And that's what investment in structure is creating optionality for the future. Now, features are easy to see and options are hard to see, but that is economically why we're investing in software, to increase the optionality. So, an uncomfortable part of this process for me is I find myself now talking to non-technical executives and trying to explain to them in their language, okay, there's some cash flows associated with your business, but there's also this embedded optionality. And what we're trying to do is increase value by increasing optionality. And this is back to the why you don't spend months and months refactoring. Try and make that argument. Okay, we're going to spend 6 months getting rid of tech debt, paying down tech debt, at the end of which you'll have exactly the software that you have today. It's not a compelling sales pitch. But there really is economic value being created in the sense that you have new options once you've done that work. Now, stopping features for 6 months is a bad idea for relationship reasons. We'll talk about that a little bit more in a second. There's an interesting tension between net present value and optionality. Sometimes you say, okay, well, I want this feature, but I also want to do this design, and I can't do both. Which should I do first? Do I do the feature? Every feature should change net present value. It should either increase revenue, draw revenue in, decrease costs, or push costs out in the future. Every feature. I want to do that, but I also want to have these options. And I can't have both. Which one do I have? There's genuine tension. And that intuition I was talking about at the beginning, where we feel like, oh, we're not investing enough in the structure, that's exactly that moment of what's the right balance? What are we going to do next? How are we going to do it? And how are we going to do it in a way that preserves and enhances the relationships on the whole team? So we have these difficult human constraints on software design. People not aligned. What's required to align us is discouraged by the structure of our companies. We have these economic constraints on software design. Wanting to spend later, earn sooner, versus sometimes wanting to have more options for what we do in the future. Now we can talk about geeky stuff. So software as a medium has some interesting magical properties. The first one is what I call Constantine's equivalence. So going back to that structured design book, one of the first observations was the cost of the software is almost entirely the cost of changing the software, not writing it up front. So the cost of software is the cost of changing it. But not all changes are the same. There are some changes that are surprisingly expensive and some changes that are surprisingly cheap. If we add up all those surprisingly expensive changes, that's most of the cost of the software. So the cost of the software is the cost of changes, and the cost of changes is pretty much equivalent of the cost of those really big changes. Then the question in the book is, how do those really big changes come about? And those changes come about when we say, it's not, I have a feature, I have a feature, I have a feature, I have a really big feature. No, it's, I have a feature, another feature, another feature. They all feel the same size. They're taking 1 week each. Oh, this one's going to take us 8 months to do. Oof. Why does this one take 8 months? Well, it's not because the feature is so large. It's because the structure of the software propagates change. If I change this in the database, then I have to change this in the code. And if I change this in the code, then I have to change these 14 modules. And if I change this module, then I have to change. It's that ripple effect of going from what seemingly one change to many changes, to many more changes, to many more changes. That is the structure of what we work with. Now, people ask, why can't we estimate software development? Okay, so this is the analogy that popped into my head, so I'm just going to say it. Why can't you estimate how long it's going to take to walk across a minefield? There are these events that cause it to be much more expensive than expected. Now, it turns out, looking at the structure of these kind of cascading changes, it's exactly the same structure as results in avalanches and hurricanes and wealth inequality. And it's essentially this rich get richer phenomenon. And I have a whole long rabbit hole about that, which I won't go into today. But for software, we have to deal with the right color. We have to deal with this Constantine's equivalence. And what creates Constantine's equivalence is exactly coupling. So this is one of the things about this process that's bothered me, the coupling had a very specific definition back then. And this is the book that introduced the words coupling and cohesion. So there was a very specific definition. And now when people talk about coupling, is kind of loosey-goosey, and they're talking about a lot of different things. So I'm going back to the original definition of coupling, and I'm going to call that coupling, and I'm going to call everything else something else. And we'll see whatever you all do, because that's how language works. Coupling is if I have two elements in a software system and a change that I want to make, those two elements are coupled if and only if changing one element implies changing the other. So I have a function that calls another function. They are coupled with respect to name changes. If I change the name of the called function, I'm going to have to change all the callers too. That's what the original definition of coupling is. And where coupling gets really expensive is when you have these cascading changes, where you say, I just want to, this duplication is the simplest one. I have this code here, that code there. If I change this calculation, I better change this calculation too, or I'm going to have inconsistency in the way that the answers come out. Well, you do that, and then you do it some more, and then you do it some more, and pretty soon you're going to hit one of these jackpot changes that's really expensive. So that's the original definition of coupling. That's the definition that I use to talk about. I want to change this in a specific way. Do I have to change other things? And if so, then I have the possibility of this avalanche starting. And if not, then I'm good. So part of the job of the software designer is to find cases of potential coupling that matter and to decouple them. So, for example, if we have a server and a client, and the server reads a message and it says read an integer and then read a float and then read a string, the code on the client has to be exactly the same. So those two are coupled with respect to changes to that message format. Now, you can introduce some sort of interface definition language that they both read from, and now the server and the client are no longer coupled with respect to changes to the message format. I change it in one place, I'm finished. That is a software design move, where I take duplication, I unify it, and now I only have one place to make my changes. Now, those changes aren't going to spread, and I'm finished. So, as designers, we're juggling these costs. We have the cost of coupling, which can go up, and the more coupled, and this is oftentimes what we mean by tech debt, the more coupled the system is, the more expensive changes get in a nonlinear way. because of this cascade, cascade, cascade effect. But we also have the cost of decoupling, where even if we know how to decouple two elements, maybe we do it, maybe we don't, but we're going to have to put in effort to do it. So where are you in this trade-off space? This is the international symbol for trade-off. Where are we in that trade-off space? Where do we want to be? And with all trade-offs, you can say, what do we do to change the shape of the curves? So that's coupling. Now, cohesion similarly had a very specific definition in the book, and that was the one that took me like 8 years to figure out how to explain it. So let me see if I still remember how. Sometimes you can't see how to decouple things. Okay, I have coupling here, I keep stumbling over it, I can't get rid of it. What you can still do as a software designer is reduce the scope of that coupling. So cohesion, like stuff that goes together goes together. That's kind of the folk definition of it, but it has a very specific meaning. Let's say I have a file and there are 20 functions in it, and 2 of the functions change at the same time. They're coupled. If I change this one, I have to change that one. If I change this one, I have to change that one. That file with all 20 functions is not very cohesive. If I take those 2 functions and I put them in another file, so that if one changes, the other one changes, that file is cohesive. And the definition of cohesion, the original definition of cohesion is, an element is cohesive if all of its sub-elements are coupled. And you say, oh, but coupling is bad. Nah, the wider coupling goes, the worse it is. The narrower the scope of the coupling, the less expensive it is. So this is a software design mood, these 2 things change at the same time, so I'm going to put them together someplace away from everything else that doesn't change at the same pace. You've increased the value of the software. You've created optionality. You've made it easier to make changes by creating that cohesive element. Then there's a bunch of really cool stuff about power law distributions, which I don't have time to talk about right now. Okay, time to shift to some consequences. If you accept that there's the sun. Yeah. It was perfect timing for the talk, too. If you accept that these are the constraints on software design, human constraints about relationships and misaligned incentives, economic constraints about survival, the timing effects of revenue and costs and optionality, and the material that we work with, software. If these are the constraints, what are the consequences? And these are the consequences that I draw. The first is that software should grow like a tree grows. That is, I don't make a big thing. I start with a seed, and then it sprouts, and there's a little shoot and 2 leaves and 1 little rootlet coming out of it. And then the leaves split and become branches, and the roots grow, and. So if here I have the features that I want to implement, and here I have the design changes that I'm going to make, the question is one of timing. Do I make the design decisions before I implement features? Do I just implement features and then make design decisions? Or do I find a way to interleave the 2? And this is why I don't care about a debate about designing up front. If you're doing a little bit of if you're doing a little design, a little feature, a little design, a little feature, growing like a tree grows, then if it's like this or it's like this, who cares? Doesn't really matter. If we're making these decisions as we go along, another implication is design is just going to be an activity. It's going to take place all the time as long as the software lives, as long as we want to change the software. So I'm not going to expect, when's the design done? Never, when we decommission the system. That's the only time design is finished. Some designs, though, some design changes take a while, though. And this, let's stop for 6 months to refactor, and then you'll have exactly the software you had at the beginning. That's really bad for relationships. If we have a big chunk of design investment to make, we need to arrange it so that it's interruptible. So somebody says, well, it would take me 6 months to refactor this. I say, okay, you have 18 months. So that you can make a little design decision and then implement another feature, and then another little design decision and implement another feature. I call that interruptibility. So it feels inefficient. I'd like to just go make my design change without having to worry about putting it into production. It puts a lot of your effort at risk, and more importantly, damages your relationship with the people who really do need more features. If I want to make design interruptible in this sense, where I can make 10% of the design change and then implement another feature and then 10 more percent. The key technical skill there is what I'm calling in the new book parallels. Let's see. This is the idea that you're going to have the old design and the new design living together for a while. So if I have a service and I'm going to replace it with a new service, I don't just work really hard on the new service, switch over and pray. Nobody would do that except people doing that. Instead, I'm going to bring up the new service in a way that's reversible, so I can throw it away if I want to. I'm going to start feeding live data into it. At some point, that'll become stable enough I can migrate all the old data. At some point, that'll become stable enough that I can start reading from the new service, and when it's finished, then I can decommission the old service. This idea of if I want design to be interruptible, I want to be able to keep the old design and the new design at the same time. It's messy, it's worse, but it's one of the uncomfortable truths of the world is that things always get worse before they get better. The second comfortable truth is even if you don't think you can take it, you can probably take it. So, parallels and I think that's it. So here we have software design in context. We have this loop from ideas to features, but also structure enabling that loop from ideas to features. Then we have some serious constraints on how we're going to invest more in structure. Human constraints, economic constraints, software constraints, because this medium that we manipulate is unusual in human experience. And then there's a set of consequences. Now, I've been challenging people's beliefs for quite a while in my career. And I get very strong reactions when I present something like this. What I'd like to encourage you to do, don't design the way I design. Figure out how you want to design. But these are the constraints. You can ignore the constraints, but the constraints are not going to ignore you. I think it's okay. As designers, we can learn to navigate this difficult landscape and find our way to greater value over time. I'm delighted when the next generation surpasses me. I have a child who's in software engineering leadership, and it's wonderful to be told things that scare me. I'd love to see that. But I would like to see it in the direction of more incrementality, more paying attention to the human side of software design, a greater mastery of the set of skills required to deliver this so that we can deliver more of the value that we see in possible in software design. What I'd like to do, I have a few minutes now. I have a rant about AI. Apparently, people are worried about this just now. So I have a rant about AI. I'm going to give you the 10-minute version, 10-minute geeky version about why you don't have to worry about your jobs. The reality may turn out to be very different, but worrying about your jobs today probably isn't helping. So maybe this will help. So let's say we're expending too much electricity on electric lights. So we make a more efficient light bulb. Does electricity consumption go up or down? Right, the obvious answer is down. William Jevons was a natural philosopher, I guess you'd say, scientist in Britain, and he noticed that when the Newcomen steam engine was starting to use too much coal, along came James Watt and made a more efficient steam engine. And the consumption of coal, which they were running out of, the consumption of coal increased, didn't decrease. This is called Jevons paradox, where if you're concerned about the consumption of a resource, you increase efficiency, and that consumption of the resource increases, not decreases. What's going on here? Well, just as with the electric lights, the steam engine, if the steam engine costs so much to run, there's only so many economic uses for a steam engine. But if you make it cheaper, there's a lot of other uses for a steam engine too, and you think, well, we can make fabric with it. We can do a lot of other things. And so people found more and more uses for steam engines, so many uses for steam engines that the consumption of coal actually increased. Now, another part of this system in the coal world is much of the steam power was being used to pump water out of coal mines. So the increased use of steam engines made available more coal, so when they consumed more coal, it was fine, they were producing more coal. I love systems like this. What does all that mean for AI and programmers? You know, AI is coming for your jobs. Now, we should acknowledge that the people who are saying, wow, we get to get rid of all the programmers, they have a point. We're not necessarily the easiest people to talk to in the world, but it's still not going to happen. And it's not going to happen for exactly the same reasons. Just as when electric lights are cheaper, we find more uses for electric lights. When programming becomes cheaper, we're going to find more uses for programming kind of thinking that we wouldn't have imagined because, oh, you couldn't hire a programmer for that. No, you can hire a programmer for that now. So if AI genuinely reduces the price of programming, it's going to increase the demand for programmers. And number two, since you're at NDC, you're the elite of programmers, the demand for the very best programmers is going to increase even faster. So for me, looking at AI, looking at programming, I think this is going to be a new golden age, especially when I hear people saying, oh, well, with AI, you can just describe what you want the software to do, and then the software will just do it. I think that's programming. By the time, like, you can't just go to an AI and say, make me a wildly profitable app. This is underspecified. You're going to have to explain what you want the app to do and what the interactions are like and what the graphics look like, and by the time you're done, you've programmed it. So I don't know if you're worried about your jobs. I don't know if that helped. But for me, yeah, and I kind of don't have skin in the game, you know, at my stage of career, but that's okay. I enjoy using AI Assist for programming. It helps my memory, which isn't what it used to be. But also, I'm not worried about it. I'm looking forward to seeing what happens in the next go-around. People are still people. The demand for more features faster isn't going to go away just because features start appearing more quickly. So that's my presentation. If anyone has a question, boy, this is a difficult environment in which to ask a question. I understand that. But does anyone have one that you'd like me to cover now? Going once? Going twice. I hope you have a fantastic conference. Use sunblock. Be good for you. And I'll be around off and on for the rest of the next couple of days. So please do find me and ask me some questions. And thank you very much.